AP Calc class, ready to go over our practice exam. All right, number one, yeah. Hello, world.
Hello,
all right,
class.
That's right, future students. Oh my gosh, 10 years from now. God, imagine where you'll be. All right, not doing calculus. Number one.
Yeah.
Maybe. Number one, false. I like it. Nice. Number one, the integral of x squared over 4 dx. The way that I approached this was, the first thing I did was I wrote 1/4 x squared dx. And you see the 1/4 is a constant. So I moved that outside to be in front of the integral. So I did 1/4, then the integral of x squared dx.
Wait, why you do 1/4?
Because it has
That
4 on the bottom. Yeah. Okay. So now, do you remember how to find the antiderivative of x squared? Go backwards. Nice. So I'm going to write down that this is 1/3 x cubed. But Michael, what was in front of the integral? 1/4. So move that next to be 1/4. When you multiply 1/4 times 1/3, you get 1/12. So I wrote down my answer is 1/12. Oop, that's 12. X cubed plus c. Find the answer that fits. I'm going to write down B. 1 for 1. Nice. Should we just stop here?
Yes.
Excellent. Everybody got 5. Let's move on. Number 2. And then it begins. Number 2. All right. What is the equation of the line that's tangent to this trig function at x equals pi over 2? Whoa, man, we haven't done this in a long time. All right. Let's see if you remember how to do it. First step. What is that? What's that mean? Find the derivative. I like it. Let's start there. I think that was a guess, but I'll take it. So let's find the derivative of cosine of x. What is the derivative of cosine? It's negative sign. Nice. Okay. Next step. Oh, nice. So plug in pi over 2. Do you know the sign of pi over 2? What is it? It's 1. Oh, Michael. It's amazing. Just think if you tried to do these problems ahead of time. Would it be negative 1? There's a negative? Where's my negative? Oh my gosh, Michael. Blame you for that one. I'm just messing. You're right, Jennifer. Thank you. It's negative 1. Appreciate you. All right. Now, do you remember what this is? Do you remember what this is?
That is your constant.
It's, who said it? Yeah. It is the slope. Nice. So we just found, right there, that is the slope of our tangent line. All right, so if you forgot how to do this, you take the derivative of your function, plug in the point it's giving you. That is the slope of your tangent line. Now, to find the equation for a line, we need a slope, and what else do we need? A point. Nice. So if they gave us the x value, how do I find the y value of this point? You're going to plug it into the original. So now I need the cosine of pi over 2. What's the cosine of pi over 2? It's 0. That's right. All right, so my ordered pair is going to be pi over 2, comma 0. All right, so that's my point. This is my point. You already know our slope. We're ready for point-slope form. Do you guys remember point-slope form? No, that's slope-intercept form. So we're going to be y minus y sub 1 equals m times x minus x subscript 1. All right, make sure you're plugging into the subscripts. All right, so our y value is 0. Our slope is negative 1. And this is going to be minus pi over 2. Do I need to write minus 0? No. That's just y. Distribute the negative. We have our answer. Two for two, Cameron?
No.
Oh, sad.
2 for 2 wrong.
Jennifer, yeah?
Ooh, so close.
Wait, you wrote?
B.
Oh.
Oh, I guess I'm right.
You guessed right, Andrew? Nice.
I said you would take B.
You were close. Questions on number 2. All right, let's go to number 3. Yes, Michael, I'm sorry.
You don't need to memorize like sine power 2, right? You can have a calculator.
Is this a calculator question?
It's not a calculator question, yeah.
Yeesh. So the answer is no, you don't have to, but don't expect to get it right. Right. Do I need to go over how that is, like how to find those right now? The quadrantals again?
Yes.
All right, so I guess I'll write it again. How many times have I done this? Gosh, I don't know. All right, so this one I always put is, that's order pair 1, 0, 0, 1, negative 1, 0, 0, negative 1. Do you remember going around in radians? So 0 radians. Pi over 2 radians.
1 half. 1 0.
Pi radians. 3 pi over 2 radians. And all the way around is 2 pi radians. In degrees? No, in degrees?
30.
90 degrees, right? 90 degrees. 180, 270, 360. Okay, now here's kind of the thing you have to remember. That's all great, but it doesn't really help you, right? So your x is going to be cosine and your y is sine. So if you look at my black ordered pairs, right? So when we said, the first one we said was the sine of pi over 2, Michael, right? Which is a good guess. The sine of pi over 2, go to pi over 2, the sine is the y value. It wasn't a guess? Okay, if you're asking these questions, it was a guess. Everybody good? So yeah, that you won't get that on the test. All right, number 3. All right, I see the symbol d dx. What does that mean to do?
Derivative.
The derivative, all right? And this is just a mega chain rule question, right? So much chain rule, all right? So the first thing I did was I looked here and I saw this power, all right? What do I do with that power?
Bring it to the front.
I bring it to the front and it multiplies by that 2, right? And what does it give me? It gives me 4 times the sine of the square root of x, and I've got to decrease my power by how many? By 1. So now instead of being raised to the second power, it's being raised to the first power.
So can you figure out C and D? What you find that is that 4?
I'm not done yet.
So you can see. So that 4 can still be reduced.
Oh, for sure. Yeah, it's about to. All right, times. All right, let's go chain rule. What's next after the 2? What's next in the problem? Sine. So what's the derivative of sine? Cosine. Okay. And then do you see the argument? Right? Do you see the argument? What's the derivative of the square root of x? Do I need to do that down here? That's x to the 1/2 power. So you put 1/2 in front. And then subtract 1, right? So what's 1/2 minus 1? Negative 1/2. All right, so I write down 1/2 times x to the negative 1/2 power. So you asked, could I like start crossing things out? Now you can, right? But you'll notice the 4 times that 1/2 was half of 4. It's going to be 2, right? So my answer here, go down here, is going to be 2 times sine times the square root of x times cosine times the square root of x. And now watch this. Do you see how this says x to the negative 1/2 power? I'm going to move that where? To the bottom, where it becomes x to the positive 1/2 power, which that's the same as writing the square root of x. What was that, Cameron? I didn't hear.
I ain't getting none of these right.
Well, the hope is that you understand how to get them right now. Remember, this test is 3 years old, right? So it's very recent.
The ratio is 1 to 2.
You got this one wrong too? That's all right. Questions on 3? Okay. Number 4. Oh, man. Does anyone have any idea what to do? It's not a derivative, right? It's an integral. Was that? Who's that? Raquel? No, Joel, that was you? Nice. It is U-substitution. Okay, Joel, I'm going to put you on the spot then. That's what you get for answering. All right. What's U then?
Is it x cubed plus 3x minus 5?
That is exactly right. Nice. Okay. Joel, I'm sticking with you. Let's take the derivative. Jennifer? Okay, Jennifer, let's take the derivative. What's the derivative of x cubed?
3x squared.
Excellent. What's the derivative of 3x plus 3? And the derivative of that negative 5? Awesome. So that's times dx. All right. Take a look in your problem. Right. We're going to do U substitution here in a moment. The U substitution takes care of the bottom, right? Because we have U cubed. Remember see that? U cubed? U cubed? Like U2?
No, it worked.
Didn't work? Okay. I tried. It's actually a think tank at Stanford. If anyone goes to Stanford. It's called U cubed. Bunch of math people. Okay, anyway. If you look at the numerator, does that look like what we have? No, but it's close, right? How can I get what we have to look like that? Take out the 3. I love it. All right. So if I take out the 3, and then don't forget, once I take it out, I got to move it, right? How do I move it over? Divide by 3. Nice. Division. So now I'm going to write it like this. Israel, it's your choice on how you want to write it, but I write it as 1/3 du equals x squared plus 1 dx. Okay, so now watch what happens when I do the U substitution. All right, so I'm going to write 1/3 times u to the negative third power times du. I'm going to pause here. I want to make sure you guys all see this, what I just did. Okay, is everybody good on the u to the negative third power? Right, that's in the bottom. It's u cubed, so I just moved it to the top and made it a negative exponent. All right, and then this numerator and dx, right, that numerator and dx is the same as 1/3 du, so I put 1/3 and du. I actually skip this step. I don't do this. I just get my brain, just put them together, and I write this immediately, so 1/3 out front. Okay. Let's see if we can find the antiderivative of u to the negative third power. Do you remember what to do with that power when you go antiderivative? By 1. You add 1, okay? Right? Because remember when we take the derivative, we subtract 1, so now we're adding 1. So it's -3 plus 1. Plus 1, -2, right? So if I took the derivative right now, where would that -2 go? It go in the front. Do I want a -2 in front? No, so what do I need in front? The reciprocal, the 1/2, okay? And some of you already noticed, do I want it to be negative? No, and right now this would multiply and give me a negative, so you have to put a -1/2, okay? Now there is still that 1/3 out there. Let's go and put that in there to give you -1/6 u to the negative second power. Now when we did this in class, right, at this point you're done, but we need to go back into the original terms. All right, we didn't start with u. All right, Joel told us we were using U substitution, so now we're ready to go back into our original. So go ahead and replace that u with our answer. Okay. I can keep going if you like, but I think we can probably see the answer at this point. It's either B or D, because I see the negative 1/6. But notice, what do I need as my U? All right, I need that whole thing, all three terms. So it's D.
I did, but I got it right.
Well done. So we've done 4 problems, right? And a lot has happened. Right? A lot has happened. Hopefully not, right? Hopefully your synapses are fired right now. Right? Making connections all over the place.
How do you know you need U-substitution?
How, Joel, tell us. You told us. How do you know? You guess.
Gotta try everything.
Yeah, right? That's like from Zootopia, right? Try everything. Yeah, great song. Oh man, such a great, just very good. This one looks much simpler. So I thought, why don't I just try antiderivative right away? Number 1, it worked out. Number 4, more complicated. I was trying to think, like, do I really want to go backwards with fractions? I didn't really know how to factor this, so I thought, okay, maybe U-substitution might work, make it look a little simpler, and sure enough, that looked a lot simpler. So I'm sure that helped. I'm sorry. Number 5. Oh my gosh. When was the last time you heard this word? Concave.
Smiley face.
Smiley face. Look at you guys, right? Concave up, cut. Okay, so the way we did this, and I know this is another like pre-Christmas, but the way we did this together was to find if your graph has intervals for a function where it's concave up or concave down, you're going to need to find the second derivative. That's the first thing you want to do. Now, let me just do a quick aside for all my followers listening, right? For this problem, if it had said, on what intervals is the graph of the function increasing or decreasing, you're going to do the exact same thing we're going to do here, but instead of with the second derivative, you're going to do this with the first derivative, okay? I'm going to repeat that. If this question just changes the problem to say, on what intervals is the function increasing or decreasing, you would do this same steps, but with the first derivative. All right, everybody good? All right, you're going to see in a moment. Okay, so let's find the first derivative, because I need to find the second derivative. So what is the first derivative?
First derivative is going to be
12x squared, I agree. Minus?
4x to the third power.
Very good. All right, again, if I was doing increasing or decreasing, I would go with this. But I'm not. I need the second derivative. Okay, so keep going. 24x.
Minus 12x squared.
Excellent. Okay? After you find the second derivative, set it equal to 0. So we're going to set this equal to 0. All right? Let's do some factoring. What can I factor out of each of these terms? 12x. So 12x, and what's left?
2 minus x.
I think it's just 2 minus x, right?
Mm-hmm.
Okay, so what makes this 0?
2.
And 0, right? Because 0 times 12 is 0. I'm going to pause here. So far, we've done minimal calculus and algebra. Everybody good? Okay, so now what you're going to do is, this is where I had you guys separate this into negative infinity to 0, then 0 to 2. Hopefully you see why I use those numbers. And then 2 to infinity. So these are your 3 options. Right, so immediately, one thing I notice is if you look in B and D, right, answer choices B and D don't even have these intervals I just said. Right, see how they have negative infinity to 3 and 0 to 3? So they got to go. So it can't be those. Okay? Now, the way you want to do this is you're going to pick a number in these intervals and be nice to yourself, okay? We're going to pick a number in these intervals and plug it in to the second derivative. The sign of our answer, I don't care what the answer is, the sign, S-I-G-N, the sign of our answer will tell us if this function is concave up or concave down. So what number am I going to choose for the first one? That's not in the negative one. That's what I'm going to choose. I'm going to change colors here. So I'm going to write down f double prime of -1. So I'm plugging this in to the second derivative. And guys, what I would highly recommend doing is you've already done this work, so just use your factors, right? That is your second derivative factor. So what happens when you multiply 12 by a negative? You get a negative. What's 2 minus -1? A positive 3. So what's a negative times a positive? A negative. So this one is concave down. All right, so our function is concave down on the interval -infinity to 0. Everybody good so far? Okay. What am I going to use for the middle one? Let's do 1. Can't do 0, right? It's got to be in the interval. All right, so I do 1. What's 12 times 1? Positive 12. 2 minus 1? Positive 1, right? So that is a positive. So there's the answer. It's concave up between 0 and 2. All right, let's do the last one just so you understand the whole process. I'm going to choose 3. 12 times 3, positive 36. 2 minus 3, that's a negative. So a positive times a negative is a negative. So the answer is C. Questions on 5. Again, I can't guarantee you get a question like this, but I'm just trying to cover all the bases. This question, they love to ask this question, and all they'll do is just change this to increasing or decreasing. It's the same steps, though. Just all the work you're doing is with the first derivative as opposed to the second derivative. Steps are the same. Let's go to 6. You guys are doing so great. My hope was to get through 10 questions. So if we get through 10, I'll be really impressed. Okay. I think we're on track. We're close. Okay. Let's go to 6. All right. It says, what is dy dx at this point 2, 8? Right? So one thing I noticed when I read this, right, is I'm thinking, this is going to be a little complicated, aka implicit differentiation. Because if you notice, we don't just have y equals a bunch of stuff with x. We have y equals a bunch of stuff that also includes another y. All right, so we have to do, it'll be a little trickier. I know, right? Why? Oh, man, I don't know why. Okay, so let's do the derivative of x. You guys know this. What's the derivative of x? It's just 1, right? So we got that one. Plus, all right? Let's do our power rule. What am I going to do for this 1/3? Bring it to the front. It multiplies by 3. What's 1/3 times 3? 1. And then I write y. And then what do I do with the 1/3? Subtract 1. So what's 1/3 minus 1? -2/3. Okay? And then here's the thing that a lot of students forget. You need to write times dy dx because this is implicit differentiation. Because this was the letter y, I need to write that dy dx. Okay? Equals. What's the derivative of y? Be careful. What's the derivative of y? Nice. It's 1 dy dx. Okay, let's see. Does anybody remember how I taught you to go from here? Differentiation. Because it's not written, this equation is not written explicitly, y in terms of x, Jennifer. It's y equals x and a y. So that's why it's called implicit differentiation, not explicit, right? Not like the, rap lyrics, right? No? Explicit? No. Trying to connect, right? No. I'm old, you're not. What do we do next? Who remembers? Thank you. Nobody remembers? Wait, Joelle has a thought. I move the dy dx's to the same side. Joelle, that's 2 for 2. Nice, Joelle. Okay, so what I personally do is I move this one. This one looks a lot like a lot's going on. I move that to this side. All right, just with subtraction. So I have 1 equals dy dx minus y to the -2/3 power dy dx. Okay, Joel, I'm sticking with you. You've had such great thoughts. Do you remember what to do next? What was the whole reason to put them together, on the same side? So you can take it out. What do we call that in math? Factor. Thank you. See, just need some help. All right, so 1 equals dy dx times 1 minus y to the negative 2/3 power. Okay, so how do I isolate dy dx? How do I get dy dx by itself? Divide by. No. I want to leave that there. Like leave this here. So move this whole thing back over to the other side. All right? Let's see if you're okay with that. Okay, so how are we doing? That's implicit differentiation right there. Now, unfortunately, the problem isn't done. The problem doesn't say what's dy dx. It says what is dy dx evaluated at a point. Right? Do you see what point it gave us? 2,8. So it says evaluate this at 2,8. Now, one thing I noticed about this, right, because when we took the derivative of x, that just became 1. Do we even have an x value here? No. So I just want to make sure you understand that even though I'm not going to plug in 2, it's not because you don't plug in 2. It's just there's no x to plug it into. Okay? Did everybody catch that? And I had a little fun there at the end. Yes? So the idea is like if there was like x minus y to the negative 2/3 power, I would be plugging in the x value. Okay, cool. So I'm just plugging in y is 8. So this is going to be equal to 1 over 1 minus 8 to the negative 2/3 power. Sadly, Michael, can't just type this into Desmos. I know. We live in a weird world where that's not a thing, unfortunately. All right? So I'll write it again for you. That's 1 minus, oh man, it's getting small. 1 over 8. I'll do a little sidebar here for 8 to the 2/3 power, right? And if you don't get this right, I can only blame myself, all right, except for Annie. If she doesn't get it right, I'll blame someone else, okay? Do you remember how to rewrite this with a radical symbol?
With the 3 in the front.
2 in the 2
Be specific on where it goes. Annie, don't say anything because I'm sure you.
2 in
The hook? All right, what is this, Maui? Come on. Thank you, Michael. Gosh, it's amazing what you remember. And then where else? Sorry, Natalie, I know you were saying things. Natalie, you have other things for me? 2. You want to put the 2 inside? Let's put the big number somewhere first. 8 inside. You want to put the 2 inside? I'm cool with that. We can do that. All right. Just to let you know, I like to write it usually like this, but they're the same thing. Okay. The reason is usually, Natalie, not always the case, Natalie, but usually, right, students have more success this way. Not always. All right, because you get the same thing. Okay. What's the cube root of 8? It's 2. What's 2 squared? 4. Let's try the other way. What's 8 squared? 64. What's the cube root of 64? It's 4. So you get the same thing. All right. So this becomes, oh my gosh, this is scary stuff. Don't try to make any money on this. Okay. 1 minus. We said that's 1 over. And what was 8 to the 2/3 power? What was 8 to the 2/3 power? It was 4. Oh my God. We're so close. Oh my gosh. Okay. What's 1 minus 1/4? 3/4. Is that the answer, Michael? No, it's 1 over that. So what's 1 over 3/4? 4/3. Oh, what a day. Wow. Amazing.
Approximately how much time do we have for like one problem?
Yeah. I mean, I did that problem. I've done it multiple times now. 45 seconds to do that problem. You just gotta go fast, right? Just think Sonic the whole time, right? Gotta go fast. I have not. Don't spoil it. I mean, I can give you a breakdown of like each problem, right? I would say it's the way it is with any AP exam. Any is like number 1, you should do in 30 seconds, right? Number 2, much longer, a lot more to do, right? 60 seconds, 90 seconds. But if you're taking more than 2 minutes, 3 minutes, you should skip it. or put your favorite letter. Okay. Ready for 7? Ready for 7? All right, I see d dx again. Just find the derivative. Boom. All right, let's do it. What's the derivative of x to the 5th power? Excellent. Now, unfortunately, this one you may not know or remember, all right, from our formula sheet. The way you do it, when you don't have the natural exponential one, right, this is different because it's just a base of 5, not a base of e. You copy it down, right? So I just copied it down. Then in front of it, you put the natural log of that base. Is d. Right, so any in that one, you should be doing that in 30 seconds max. Right, I mean, that's the idea. It's like some of them will be much longer, much quicker. All right, let's do number 8. All right, number 8. Now this one's pretty tough. All right, not that some of them haven't been tough, but this one is really tough. Oh my, you forgot all about limits? Luckily, you're going to do those IXL links, right, on limits?
Yeah.
Okay. All right. So the limit as x approaches infinity, right? Now, what's kind of the first thing? Well, I think the first thing. What's something that we've tried when evaluating limits? Does anyone remember any strategies to try to evaluate a limit? That's what I always do is plug it in, right? It says infinity, so what do you want to plug in? 12. I plug in a very large number, right? Yeah, that's getting there, right? Maybe 10 million, right? A very large number. Let's see what happens, okay? Very large number, squared, getting larger, right? Times 6, still larger, right? 10 minus that.
Boy, it's still a big number.
It's going to be negative of infinity, right? Negative infinity, maybe? Okay. Well, let's wait for it. Right. The denominator. Okay. What about the denominator?
When I saw E, I thought it.
E to a really large number?
E to a really large number. Don't be a really large number.
Really big number. Okay. Times? 3. Big number. Huh?
Plus 5.
Plus 5. Okay. Bigger number. Okay. You know the answer yet?
It's going to be -2.
No. Here's how you do the answer. And this is one of those where I'm just like, I wish I could use Desmos to show you. Okay. If I were to graph these, right, separately, okay, you would see that e to the power of x increases faster than the numerator. Okay? And because that denominator is increasing faster than the numerator, you're going to end up converging as you get towards infinity at 0. So this is one of those questions where I would like to have a word with the College Board. Why can't we use graphs? Right? In no world would you not be able to see what it looks like.
You should send them a stronger word.
You know what? I might do that. But I don't want them to take away my authorization to teach AP, right? Because that helps you guys. Doesn't help me, it helps you.
We shall let you know. They just get a whole bunch of students.
All right, let's do number 9. I think we're going to make it. Although number 9 is a lot of work. Okay, so Andy, this would be one of those
Wait, so what was
that
that?
take you many minutes. It's 0. Did you get it right?
No?
Okay. Okay. Let's see what you guys remember about this. If you read this question, you have R, capital R, is the region bounded by this graph of a linear function and the graph of a quadratic function. What is the area of R? Do you remember what question of calculus this is asking for? Like just like broad. Say it again. The area underneath the two curves. Very good. Or between the two curves. Right? Is that physics? Look at that. See? You can't do physics without this. Okay? So this is integral calculus, one of the two main things you needed to learn in this class. So, okay, we got that idea. So, first thing I do is I actually want to try to figure out how to graph these. I know one is a line, one is a parabola. Let's get a little bit more specific, right? You know, if this was the real world, what would I do? I would just graph them, right? I don't know why we can't. That's okay. So the first thing I do is I set them equal to each other. Strong. It's getting the words are getting stronger. All right. Oh, like maybe some bold, some caps. Okay. So you set them equal to each other to see where they're going to intersect. I'm going to repeat that, Cameron. You're going to set them, when you get this question, guarantee you get a question like this. Set them equal to each other to see where they intersect. Okay? So now I'm going to solve this. Let's see if your brain's good with this. So I'm going to move the x squared over to make it positive. Move the 4x over to make this minus 2x equals 0. Let that marinate a little bit in your brain. Right? That's algebra. So I move the x squared over to make it positive. Move the 4x over with subtraction. Okay, let's factor. What can I factor out? X.
X minus 2.
Nice. So where are these functions going to be intersecting each other? At 0 and 2. Okay, so then I did like a quick little sketch. Do you want me to use different colors for the different functions?
Yes.
Okay. All right, I think we can graph the line pretty quickly, right? 2 times 0 is 0. All right, what's 2 times 1? Is 2. 2 times 2? 4. 2 times 3. See where I'm going, right? I'm graphing that line. This is the line. All right, I'm good. All right, let's graph the parabola. Okay, so I'm plugging into this one, right? Right. You should know by now if I plug in 0 here, what am I going to get? 0. Are you surprised by that they intersected 0? Hopefully not, right? That's one of our intersection points. All right, let's plug in 1. What's 4 times 1? And then 1 squared. 1, 4 minus 1 is 3, so that's going to be up here. It's a little bit higher. Why is that 3? I'm plugging into this one here. 4 times 1 is 4. 1 squared is 1. 4 minus 1 is 3. I'm just trying to sketch it. All right, let's plug in 2, right? You probably know what it is. What's 4 times 2? 8. 2 squared. 8 minus 4. Are you surprised that they're intersecting there? No, that's one of our other points. Okay. And then let's plug in 3, one more. What's 4 times 3? 3 squared. 12 minus 9? 3. So that's down here. If you're hearing someone breathing heavily, it's just because they're enjoying this class so much they wanted to take a quick nap. All right. Now remember what Israel just said. We're trying to find the area between the curves. You guys see it? Do you see the area between the curves? Right here that I'm going to put in green. Okay. Now let's see what you remember. Okay. So this is called integral calculus. So I'm going to do the integral. Okay. What's my lowest x value? 0. Where do I stop? Where do they hit each other again? No, where do they hit each other again? 2, right? That's the whole point of doing that. So 0 to 2. Okay. Which one is above? Which one's on top? Which one's on top? The blue curve, right? The parabola. So I need to do that one first. So it's going to be 4x minus x squared minus what's on bottom? The red line, right? The linear function, so minus 2x. All of that dx. All right. Let's clean it up a little bit. I'm going to combine like terms. So I'm going to write negative x squared. What's 4x minus 2x? 2x. All right. I think we're ready to find the antiderivative. Hopefully you guys remember how to do this. I know. We've done this a lot. I know you're like, I haven't done it. We've done this. Okay? That's a derivative. Go the other way. Antiderivative. Nice. I heard somebody say it. 1/3 x cubed, but you need a negative. Nice. Okay, so I just negative x squared minus 0, no like terms, so I brought it down. 4x minus 2x. Just combine like terms. Plus? Just x squared, right? Because if I take the derivative of x squared, that is 2x. All right? Then here's how you write the notation, right? Put in the parentheses. Remember that bar? Remember that bar? It's been a while. Remember the bar? All right, we need to evaluate this at 2 and at 0, right? If you remember, we used a capital letter F for this. That capital letter means what? It's the antiderivative of our function. It's the antiderivative. I know, gosh, this is so fun. Oh, man, I'm having a great time. So we're going to do f of 2 minus f of 0. Why am I so happy right now? Because of 0, right? When I plug in 0, I don't need to do that one, right? It's just going to be 0. So I really just need to focus on plugging in 2. I know some of you are thinking, gosh, I wish I just had a calculator right now. Me too. But alas, we do not. 2 cubed. So negative 8 thirds plus 4. How can you rewrite 4? 12 thirds. Oh my gosh, did we get it? Did we get the answer? Oh my gosh, where is it? So much work. It's 4 thirds. All that work for 4 thirds. Wow. Man, how long did that take us? Too long. One more. Yes. Oh man, the Riemann sum? Yeah, that's what it's called. Man, I hope so, right? Good times. All right, let's do 10 and we'll be done. All right, last one. So it tells us this graph. Yeah, I'm sorry, Andrew. Did you go back?
Can I get another piece of paper?
Yeah, you can. My bad. Oh man, well done, Andrew. God, I hope Andrews are having a great day all around. Oh, for sure. All right. So in this one, they give you the graph of the function f, and they give you that g is defined by x squared plus 1 over that function f. What is the value of g prime of 2? So that's the derivative of g. Now, when I look at this, right, if I look at g of x, and I want to find the derivative of this, you notice we have a numerator and a denominator. So you know what rule I'm going to use to find the derivative of that? The quotient rule, right? Division. The quotient rule. Do you remember it, Andrew? No. The first. Okay, hold on. The first one. So okay. The derivative of the first one. Can you do it for me? What's the derivative of the numerator? X squared plus 1. The derivative. Times the original denominator. There we go. Minus. Okay, so f prime of x times. Awesome. All over. Here we go. Michael. Oh my goodness. I know you love the fact that you know that, right? That makes you so happy. Again, right? I don't know why I can't give you the formula for that, but I cannot. So there you go. Now we're going to basically plug into where you see x. So I'm going to do 2 times 2 times. Now this is f of 2. Can you guys do this if I don't show the step? Jennifer, let's see if you can do it. Right, I do f of 2, right? So I'm going to do f of 2. What do they give me? They gave me the graph, right? So what is f of 2? Ready? What's f of 2? It's 3. Nice. Minus, okay, this is where we're going to get mad at me, okay? Do you see the function f? All right? We want to do f prime at 2. So this is how you do it. You go to 2, right? You see where it is? What's the slope of that line? Ready? 1, 2, 3, 4 over 1. So what's f prime of 2? It's 4. Nice, Israel. Okay, we can plug in 2 here. What's 2 squared? 4 plus 1. And then if I plug in, well, we said it was 2, right? F of 2 was 3. Yeah, remember that? F of 2 is 3. What's that squared? 9. All right, so what's that? 4 times 3 is 12 minus 20 over 9. Oh my gosh. Did we get it? Did you guys get it? Did you get it, Jennifer? It was A? All right, I'm going to pause here. Thank you guys for tuning in. Please join us with part 2 next.
Goodbye.